In this video, we're going to look at the measures of variation. And to do this, we're going to start off by looking at an example. In this example, we're going to be testing out outdoor paint for two different brands, and we want to see how many months it takes for each gallon of can to fade. With brand A, we have 10 months, 60 months, 50, 30, 40, and 20 months. Brand B has 35, 45, 30, 35, 40, and 25 months. And what we'll start off with is we looked at measures of central tendency in the previous section, so let's find out what their means are. These are our populations, so we're going to find the population mean. For brand A, we got mu. We're going to add up all of our data points, and we're going to divide it by the number of data values we have for brand A, which would be 6. Add up all of our months, divided by 6, which would give us about 35 months. So on average, brand A takes about 35 months to have the color fade. Brand B, add up all of their values, divided by 6 as well. Take our numbers 35 through the 25, add them up, we end up getting 35 months again. So it looks like, hey, it doesn't matter which brand that we're going to buy, it's always going to be around 35 months for the paint to fade. But if you look at the values, you see, well, brand A has one that goes all the way down to 10 months, but all the way up to 60 months. But brand B, it always seems to be in the 30s and the 40s, or maybe one that drops down into the 20s. So next question is, well, how often are these data points going to be varying? So the mean for both of these brands are exactly the same, but the number of months for each can definitely varied. And that's where the variation measures come into place. So the most common measures that we use for spread and variability of the data, the first one is really common, called the range. Then we have the variance and the standard deviation. So we're going to start off simple. We're going to find the range of these values. And we probably know this back from some of our earlier math classes. The range, which we could represent with a capital R, it's just by taking the highest value minus the lowest value. So reminding ourselves again of all the data that we have from brand A and brand B, let's find the range for A. Brand A, well, the highest value that we have is 60 months all the way down to 10 months, so that is a range of 50 months. That's a 50-month swing in their fading. Whereas the range for brand B, its highest value was 45 and its lowest value was 25, so therefore it varied 20 months. So we're thinking, well, although they had the same average, brand B definitely had values that were much, much closer to the actual average on this. So leading into the next thing, what is the population variance? How often are these data points varying? That's by definition is the distance each value is from the mean. How far away is every data point from the average? So we're going to look at a new definition here. First, X, capital X, is going to be all of our individual values in our data. Mu, the mean, is the population mean. And capital N is the population size. So how many data points do we have in our population? This is represented by what we call sigma squared. This is the Greek letter for the lowercase sigma. You don't be confused here that we have capital sigma, which is sum. Little sigma just represents, or sigma squared would represent the population variance. So how do we find the population variance of a data set? Actually, before I jump into that, let's talk about the population standard deviation. So first, we start off, well, here is our variance formula. We're going back to some algebra skills here. We want to get rid of the exponent. Well, we're just going to square root both sides, get rid of the square, cancel out the square on the left side. So the Greek letter sigma, this is the standard deviation, is equal to the square root of the variance. So when we calculate our variance, we'll just go ahead and square root that number, and that'll be what the standard deviation value is. So steps to finding the variance and the standard deviation. Well, step one, we have got to figure out what the average is. So we're going to add up all of our data points divided by how many points we had, and that'll be our average. Because what we can do then is find the deviation. How far away are our data points from the average? Once we get all of those deviations, we're going to square each of those values and then add up all those square terms that we have. Once we have all those data points added up, well then we're going to divide it by the number of data points that we have, and that's going to give us our variance. Once we get the variance, if we need to calculate the standard deviation, we'll square root that number, and that will give us what the standard deviation is for the data set. So talked about brand A, talked about brand B. Let's find some variance. Let's find some standard deviation. All right, so find a variance, find the standard deviation of just brand A. Well, first step, we need to figure out what the mean is. We've already calculated it once, but let's go ahead and add it up there again. There's mu for brand A, which is 35 months. Now we're gonna go through and figure out, well, how far away is 10 from 35? How far away is 60? How far away is 50? All the way through each data point. So that's what our x minus mu is. When we take all those data points, we subtract them, we're going to get the following values. Negative 25, 25, 15, negative 5, 5, and negative 15. Then we jump into step 3. We're going to take each of those values and we want to square them. So all of the negatives, all those positives that we have in red, we'll raise them to the second power and we're going to get the following values here. A couple 625s, a couple 225s, and a couple 25s. And then we take each of those numbers that we get from the squaring and we're going to add all them up. Add each of the values up. That's going to give us a total of 1,750. And then get into step 5. This is where we find the actual variance of the problem. We'll remind ourselves, how many data points did we have? We had a total of 6 cans that we were going to have check. So we're going to divide by 6, which rounds to a decimal value of 291.7. So our, not our standard deviation, but our variance is going to be 291.7. So if I need to calculate the standard deviation from this, we will square root that value. And the square root of 291.7 is 17.1, about 17.1. So there's our standard deviation. So what this means is that all of our data points are about 17.1 steps away from the actual average that we calculated. Well, sometimes our population is going to be extremely large and that we're not going to be able to go through and calculate an actual population mean or a population variance and standard deviation. We need to collect a sample from that. So we're going to go in and say, well, what's our sample variance and our sample standard deviation? These are slightly different formulas here. With our sample comes in with a little bit of different notation. Instead of using the Greek letter sigma, we're going to use S. S squared will be the variance and S will be the standard deviation. Instead of using mu for the mean, x bar is also another way for us to represent the mean. So we'll use x bar for sample mean. And our sample size will be little n. And a slight change in here is that instead of dividing by n being the entire population, we're going to subtract 1 away from the sample size to come up with our variance and our standard deviation. But as far as calculating all these steps, they're all exactly the same. We still need to find the mean first, figure out our deviations, square those terms, add them all up and divide it by n minus 1, and then we could do the square root to find the standard deviation. So let's look at a second example. The number of public school teachers, they went on strike in Pennsylvania this is the random sample, so we collected just a small amount of data from all these schools in Pennsylvania. We're going to find the variance, we're going to find the standard deviation. Well, first, nothing different. Let's add all these data points up. Let's find the average. Doing this, we get 51 divided by 6, or about 8.5. Okay, how far away are all of our data points from 8.5? Let's do some subtraction. These values will give us 0.5, 1.5, 5.5, negative 1.5, and negative 0.5, and a final negative 5.5. Once we get these values, we take each one of them, we're going to square them to get the following decimal values here, which gives us the step 4. Let's add up all those decimal values, giving a total of 65.5. Now, normally we would divide by the number of data points that we have here, but since we're doing a sample, we're going to go with n minus 1. Well, we had 6 samples, subtract 1, we're dividing by 5. 65.5 divided by 5 gives us 13.1. So this value here we will call s squared. If I want to find the standard deviation, we'll square root that number. So s would equal the square root of 13.1, which is about 3.6. So there is our standard deviation. What you can see then is that if we had hundreds of data points that we would use in our sample, this gets quite lengthy and pretty cumbersome. It's not a difficult process, but it takes a while. And this is where our graphing calculator is going to come in handy here. So we got some shortcuts that we can use here. With the graphing calculator, one, we need to enter our data into L1. We do that by hitting Stat, Edit, enter our data, and we've already gone over this. Second, we're going to calculate what we call one-bar stats. So once we enter in our data, to do this, we're going to hit Stat, hit the right arrow, and option 1 is what we're going to pick. You should see this on your screen here, which is one bar stat, one variable stat. We're only calculating with one variable. When you click that screen, you need to choose the list that you put all your data in, if you had a frequency list, and calculate. So here, in this case, we can enter our data in. I'm using the example with the teacher strike. We entered into L1. We did not track any frequencies, so I don't have a list in frequency list. And then I'll just keep entering, hitting enter until I get to calculate, and the following screen is going to pop up. There's a lot of information on this screen. One of the information is the 8.5. That's the mean that we calculated earlier. The next thing is we have a sample standard deviation with the S. The sigma notation would tell us this is the population standard deviation, so it does those formulas for us. And the final data point is the n equal to 6. That's because we had a sample size of 6, or if we're doing a population size, then that's our population size. So there's a lot of information you can find from this following screen. Now that gives us sample and population standard deviation. How can we calculate the variance that goes with this? We can, or once we hit equals, all of these data points are saved into the calculator. So we can recall all those data points. And to do that, we can click on the VARs button. If you look at the arrow buttons, right below the down arrow, there is a VARS standing for variables. When you click that, the screen will pop up like so. Highlight number 5, or you could just click on option 5. That's statistics, and then you'll get the following screen here, and there's all of your sample size, your mean, your sample variance, your sample standard deviation, your population standard deviation, so on. Just click on the option that we have, that we're looking for. So if we wanted to find what's the variance for the sample standard deviation, we click on option 3, raise it to the second power, and there is our variance of 13.1. Okay, if you want to repeat this process, you can go through, click all the same buttons, and do the same thing for the population standard deviation. All right. How do we calculate a variance and a standard deviation of group data? Now, if we get a group data like we have so here, where we have classes, frequencies, and midpoints, we have a couple tables that we can enter into our calculator. What I want to do then is take all of my midpoints from a class. If the midpoints aren't given to us, we need to calculate those midpoints. We're going to enter those into L1, and then we're going to enter all of our frequencies into L2. And then what we do here is that we have the following screen. L1, there's all of my midpoints. L2, there are all of the frequencies. Then I can get out of the screen, go back in and do all of the same stuff again. Go to my stat, go over to calculate, click on one variable stat. What's different you'll see though is that all of our data was listed into L1. Those were our midpoints. But then we kept track of all of our frequencies, so we need to make sure that the frequency list is now in L2. Once those are entered in, we can hit calculate, and there is our sample standard deviation for the SX that you have. If I want to find the variance, go back through, click the variables button, go down to where it says SX, raise to the second power, and then there you'll see our sample variance of 68.68, or you can round that up to 68.7. So there you go. There's how you find the sample variance, the sample standard deviation, the population variance, and the